Now, in this lecture, we will find out the length of chord AB. In the drawing, we have a semicircle, and inside this semicircle, we have three circles. Those two small circles are identical, and in the middle we have the middle circle. The middle circle is tangent to the semicircle at point O, and point O is also the center of the middle circle, and point C is point O is the center of the semicircle, and point C is the center of the middle circle. And we know that PQ equals to 8 units. PQ, it is actually the diameter of this semicircle, and the diameter is twice as large as the radius. So if the diameter of the semicircle equals to 8 units, then the radius will be equal to 4 units. That is to say, PO, that is the radius of the semicircle, equals to 4 units, and OQ, that is also the radius of the semicircle, will be equal to 4 units. Likewise, OX, that is also the radius of the semicircle, equals to 4 units, and OX, it is not only the radius of the semicircle, but it is also the diameter of the middle circle. So we know that the diameter OX of the middle circle equals to 4 units. Therefore, the radius of this middle circle will be equal to 2 units. That is to say, CX equals to 2 units, and OC, that is also the radius of this middle circle, will be equal to 2 units. And we also know that AB, the chord that we are looking for, equals to PQ. AB is parallel to PQ. Okay, AB is parallel to PQ. So we will define the center of this small circle as point M. Then we will join points M and C by a straight line. Points M and C are the centers of those circles. Point M is the center of the small circle, and point C is the center of the middle circle. So we will join points M and C by a straight line. Actually, the distance between the centers of those two circles is MC, and the distance between two circles that have an external lunge between them, like in this drawing, it equals to the sum of the lengths of their radiuses. So we will define the lunge point between the two circles or the touching point as point Y. And if we define the radius of the small circle as R, so actually the distance between point M and point Y is R, and the distance between point Y and point C, it equals to the radius of the middle circle. That is to say, it equals to 2 units, because the radius of the middle circle equals to 2 units. So in total we found out that MC, that is the distance between the center of the small circle and the center of the middle circle, MC equals to R plus 2. Okay, so in the next step we will define the touching point between the tangent PQ and the small circle as point N. Point N, it is actually the point of tangency of tangent PQ with this small circle, and then we will join together points M and N by a straight line. So what is MN? MN is the radius of this small circle, that is to say it equals to R. And the point of tangency of tangent PQ with this small circle is point N, and as you can see from the drawing, the radius MN is drawn to the point of tangency, that is to say it is drawn to point N, that is the point of tangency of tangent PQ with this small circle. Therefore, we have the rule that whenever a radius is drawn to the point of tangency, then the tangent PQ will be perpendicular to this radius. That is to say, this angle will be equal to 90 degrees, and this angle will be also equal to 90 degrees. Okay? Likewise, we have the radius CO of the middle circle. It is drawn to point O, that is the point of tangency of tangent PQ with this middle circle. Therefore, according to the rule that I mentioned, the radius, the tangent PQ will be perpendicular to this radius OC. That is to say, this angle will be equal to 90 degrees, and this angle will be also equal to 90 degrees. Okay? In the next step, I will draw perpendicular to CO from point M. Again, from point M, I will draw perpendicular to CO. So this angle will be equal to 90 degrees, and this angle will be also equal to 90 degrees because this is perpendicular to CO. Therefore, this angle equals to 90 degrees and this angle equals to 90 degrees. And we will define the touching point between the perpendicular and CO as point D. And we will also define this point as point E. In the next step, I will draw again the perpendicular MNDO and the right triangle triangle MCD. Okay, so we actually have the perpendicular NMOP, so I will draw it in a new page. I will repeat again that AB is perpendicular to PQ. So I actually draw again the perpendicular MDON and the right triangle CDM, and I repeat again that here chord AB, this chord AB is parallel to PQ, and we have rule number one. According to rule number one, according to rule number 1, corresponding angles between parallel lines are equal to each other. So I will read rule number 1 again. According to rule number 1, corresponding angles between parallel lines are equal to each other. So here we know that AB is parallel to PQ, and those two angles are defined as corresponding angles, and they are located between the parallel lines AB and PQ. Okay, so this angle equals to 90 degrees, angle POC equals to 90 degrees, and this angle is angle CEY. So those two angles are corresponding angles, and because of the fact that they are located between the parallel lines AB and PQ, they are equal to each other. That is to say, this angle that equals to 90 degrees equals to angle CY. So according to rule number 1, this angle is angle CY, and it equals to this angle that is a right angle, that is to say it equals to 90 degrees. I will repeat again. Because of the fact that AB is parallel to PQ, AB is parallel to PQ, and those two angles are located between the parallel lines AB and PQ. They are equal to each other. That is to say, this angle, that is angle CEY, equals to this angle that equals to 90 degrees. Or angle CEY equals to 90 degrees. So this angle equals to 90 degrees according to rule number 1. I repeat again, because those two corresponding angles that are located between the parallel lines AB and PQ, they are equal to each other. That is to say, this angle equals 90 degrees, so it equals to angle CY. Therefore, angle CY equals to 90 degrees. Likewise, because of the fact that AB is parallel to PQ, those two corresponding angles will be also equal to each other. Okay, so angle CEB, this angle will be equal to this angle, that is actually a right angle. It equals to 90 degrees, according to rule number 1. Or, in other words, angle CEB equals to 90 degrees, according to rule number 1. Why? Because those two angles that are corresponding angles, they are equal to each other because they are located between the parallel lines AB and PQ. That is to say, this angle, that is angle CEB, this angle is angle CEB, it equals to the corresponding angle, this angle, that is actually 90 degrees. Or angle CEB equals to 90 degrees. So this angle is a right angle. It equals to 90 degrees. Okay? So in the next step, we will focus on quadrilateral MNOD. Okay? So on this quadrilateral MNOD, or before that, I will present to you a new rule number 2. According to rule number 2, the sum of the angles in any quadrilateral equals to 360 degrees. So I'll read rule number 2 again. According to rule number 2, the sum of the angles in any quadrilateral equals to 360 degrees. So if we focus on quadrilateral MNOD, this quadrilateral, we know that the sum of the angles in quadrilateral MNOD, this quadrilateral, equals to 360 degrees. Okay, so the sum of the angles in quadrilateral MNOD is equal to 360 degrees. We know that in this quadrilateral we have 3 right angles, 1, 2, 3. And the sum of 3 right angles is 90 times 3 is 270 degrees, plus the size of this angle that we will define as angle X. In total, the sum of those 4 angles must be equal to 360 degrees according to rule number 2. I repeat again. The sum of the angles in quadrilateral MNOD equals to the sum of 3 angles. The sum of 3 right angles is 270 degrees, plus the size of the 4th angle that is defined as angle X must be equal to 360 degrees according to rule number 2. Here we will subtract from this equality 270 degrees, and we will get that angle X equals to 360 degrees minus 270 degrees. It is actually 90 degrees. So we actually found out that this angle is a right angle, it equals to 90 degrees. So this is a right angle, it equals to 90 degrees. So as you can see, in quadrilateral MNOD, all its angles are right angles. And we also have rule number 3. According to rule number 3, any quadrilateral that has 4 right angles must be at least a rectangle if not a square. So I'll read rule number 3 again. According to rule number 3, any quadrilateral that has 4 right angles must be at least a rectangle if not a square. Therefore, we will relate to quadrilateral MNOD. This quadrilateral is a rectangle because it has 4 right angles, and according to rule number 3, it must be at least a rectangle if not a square. Okay, and we also have rule number 4. According to rule number 4, the opposite sides of a rectangle are equal to each other. So I will read rule number 4 again. According to rule number 4, the opposite sides of a rectangle are equal to each other. And we actually know that Mn equals to R. It is the radius of the small circle. Therefore, here Mn equals to R, and according to rule number 4, Mn equals to, in rectangle MNOD, Mn equals to DO. Okay? Because Mn is opposite to DO, therefore according to rule number 4, that the opposite sides of a rectangle are equal to each other, Mn equals to DO. I'll repeat again. Mn equals to DO according to rule number 4, that the opposite sides in a rectangle are equal to each other. But we know that Mn equals to R. So I can write here that Mn equals to R. So from this equality, R equals to Mn equals to DO, we will conclude that DO also equals to R. Okay, DO equals to R. So here we can write down that DO equals to R. And what is the length of CO? The length of CO, as you can see from the original drawing, CO is the radius of the middle circle, therefore it equals to 2 units. CO equals to 2 units. It is the radius of the middle circle, so CO equals to 2 units. It is the radius of the middle circle. CO equals to 2. And we know that DO equals to R. So what is the value of CD? On the drawing you can see that CD equals to CO minus DO. Again, CD equals to CO minus DO. I will write it down. CD equals to CO minus DO. You can see from the drawing that CD equals to CO minus DO. Okay? And we know that we know that CO equals to 2 units and DO equals to R. So in total we will get that CD equals to 2 minus R. Okay, CD, this line segment CD equals to 2 minus R. Okay, and MC, that is the distance between the centers of the small circle and the middle circle. We've already found out that MC, here MC equals to R plus 2. Okay, so here we can write down that MC equals to R plus 2. Okay, so in the next step we will focus on the right triangle CDM. So on the right triangle CDM, according to the Pythagoras theorem, that the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse in the right triangle CDM is CM, so the square of the hypotenuse is CM squared. And it equals to the sum of the squares of the perpendiculars, that is to say, it equals to CD squared plus MD squared. So I will repeat again. In the right triangle CDM, according to the Pythagoras theorem, that the square of the hypotenuse equals to the sum of the squares of the perpendiculars in any right triangle. In the right triangle CDM, the square of the hypotenuse is cm square, and it equals to the sum of the squares of the perpendiculars, that is to say it equals to cd square plus md square. Okay? But we have already found out that cm equals to r plus 2, so cm square will be equal to r plus 2 square. Okay? cm square equals to r plus 2 square, and it equals to cd square. Here cd is 2 minus r, so cd square will be equal to 2 minus r square plus md square. So in total we got that r plus 2 square, according to equation number 1, r plus 2 square equals to 2 minus r square plus md square. Here we will open the brackets of equation number 1, this equation, and we will get that r plus 2 square equals to r square plus 4 plus 4r, and it equals to 2 minus r square. 2 minus r square is 4 plus r square minus 4r plus md square. So here we have r square on both sides of equation number 1, this equation. So r square will get cancelled. And we also have 4 on both sides of this equation, equation number 1, so 4 will also get cancelled. What is left from equation number 1 after we cancel those expressions? So in this side of equation number 1, only 4r is left. And on the other side of equation number 1, what is left? It is actually minus 4r plus dm squared. So I'll write it down. In total we got that 4r equals to minus 4r plus md squared. Okay, so here we will add 4r to this equation, equation number 1, and we will get that 4r plus 4r is 8r, and here in the other side of the equation 4r minus 4r is 0, so what is left is only md squared. So in total we got that 8r equals to md squared. Here we will take a root out of this equation, equation number 1, and we will get that md equals to the square root of 8r. Okay, here we took a root of this out of this equation, equation number 1, and we got that md equals to the square root of 8r. We know that 8 equals to 4 times 2, so we will substitute 8 by 4 times 2 in this equation, equation number 1. So MD equals to the square root of 4 times 2 times R. And we know that the square root of 4 is 2, so I will write it down. We will get that MD equals to 2 times square root of 2R. So we found out that MD equals to 2 times square root of 2R. So here we will write down that MD equals to 2 times square root of 2R and we have also rule number 4 that states that the opposite sides of a rectangle are equal to each other. That is to say MD equals to NO. Okay, so MD equals to NO according to rule number 4 that the opposite sides of a rectangle are equal to each other. MD equals to NO, but we already found out that MD equals to 2 times square root of 2R. So from this equality, we will conclude that NO also equals to 2 times square root of 2R. NO equals to 2 times square root of 2R. So we can write here that NO equals to 2 times square root of 2R. NO equals to 2 times square root of 2R. Okay. In the next step, we will join together points M and O, those 2 points by a straight line. We will do the same thing on the original drawing. We join together points M and O by a straight line. Then we will join together points A and M by a straight line. What is AM? AM, it is actually the radius of this small circle, that is to say it equals to R. So AM equals to R. Right here that AM equals to R. It is the radius of the small circle, this small circle. And what is the value of AO? The value of AO, it is actually the radius of the semicircle. That is to say AO equals to 4 units. AO equals to 4 units. It is the radius of the semicircle. And what is the length of line segment MO? From the drawing you can see that MO equals to AO minus AM. Again, AO minus AM equals to MO. AO minus AM equals to MO. I will repeat again. You can see from the drawing that MO equals to AO minus AM. So MO equals to AO. We already found out that AO equals to 4 units. And we have already found out that MN AM equals to R. So in total we found out that MO equals to 4 minus R. So we can write here that MO equals to 4 minus R. And here MO equals to 4 minus R. Okay, so in the next step we will focus on the right triangle, triangle MNO. We will focus on this right green triangle, triangle MNO. So on the right green triangle, triangle MNO, according to the Pythagoras theorem, that the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse in the green triangle, it is actually MO. Therefore, the square of the hypotenuse will be equal to MO squared and it equals to the sum of the squares of the perpendiculars. That is to say, it equals to MN squared plus NO squared. So I will repeat again. In the right triangle, the right green triangle, triangle MNO, according to the Pythagoras theorem that the square of the hypotenuse is equal to the sum of the squares of the perpendiculars, we will get that MO squared equals to MN squared plus NO squared. But we have already found out that MO in the green triangle equals to 4 minus R. So MO squared will be equal to 4 minus R squared. So MO squared equals to 4 minus R squared, and it equals to MN squared. MN equals to R, so MN squared will be equal to R squared plus NO squared. NO equals to 2 times square root of 2R, so NO squared will be equal to 2 times square root of 2R squared. Okay, so NO equals to 2 times square root of 2R squared. MN equals to R, so MN squared equals to R squared. And MO equals to 4R, so MO squared will be equal to 4 minus R squared. In total, we got that 4 minus R squared equals to R squared plus 2 times square root of 2R squared. Here we will open the brackets on both sides of equation number 2, and we will get that 4 minus R squared, it is actually 16 plus r squared minus 8r, and it equals to r squared plus the square of the square of 2 times square root of 2r. It is actually the square of 2 is 4, and the square of square root 2r is 2r, so in total it is 4 times 2r. 4 times 2r is 8r. So here we have r squared on both sides of equation number 2. So r squared will get cancelled. After we cancel r squared, we will add to this equation number 2, 8r. So, and we will get that 16 minus 8r plus 8r is 16, and 8r plus 8r is 16r. So in total we got that 16 equals to 16r. We will divide this equation number 2 by 16, and we will get that r equals to 1 unit. We found out that r, the radius of the small circle, equals to 1 unit. So we can write here that r equals to 1 unit, r equals to 1 unit, r equals to 1 unit, and CD, that is actually 2 minus r, will be equal to 2 minus 1. 2 minus 1 is 1, so CD equals to 1 unit, and r also equals to 1 unit. And here r plus 2 equals to 1 plus 2, that is to say it equals to 3 units. Okay, in the next step we will focus on the right triangle CYE, on this green right triangle CYE, and on the right triangle CDM, and we will prove that those two right triangles are similar to each other. Okay, so we will focus on the right green triangle CYE, and on the bigger right triangle CDM. We will prove that those two triangles are similar to each other. First of all, we know that those two angles, they are equal to each other. They are both right angles. So here angle CEY, this angle equals to this angle, that is actually angle CDM, and both those two angles are right angles, that is to say they are equal to 90 degrees. I will repeat again. Angle CEY equals, in triangle CEY, equals to angle CDM in triangle CDM, and both those two angles are right angles, they are equal to 90 degrees. And we also know that this angle is a common angle. Angle C is a common angle. Why it is a common angle? Because angle C belongs to the green triangle, and angle C also belongs to the right triangle, triangle CDM. So we can write down that angle C equals to angle C is a common angle that belongs to both triangles. I will repeat again. Angle C, angle C angle C equals to angle C. Angle C equals to angle C. It's a common angle that belongs to both triangles. Angle C equals to itself. And those two angles, they are also equal to each other according to third angle theorem. So this angle that is actually angle CYE this angle is angle CYE equals to this angle that is actually angle CMD, and they are equal to each other. Those two angles are equal to each other according to third angle theorem. I will repeat again. Angle CYE in triangle CYE equals to angle CMD in triangle CDM, and those two angles, they are equal to each other according to third angle theorem. What is third angle theorem? Third angle theorem is that states that if two angles in one triangle congruent to two angles in another triangle, then the third pair of angles must also congruent. So here we have those two. This is the first pair of angles that congruent in those two triangles. They are both right angles, therefore they are equal to each other. And this is the second pair of angles that congruent in the green triangle and triangle CDM. This angle equals to itself. So here we have two pairs of angles that congruent to each other in those two triangles. Therefore, according to third angle theorem, the third pair of angles must also congruent. That is to say, angle CYE equals to angle CMD. So those two angles are equal to each other according to third angle theorem. Because if you have in two triangles two pairs of angles that congruent to each other, then the first pair of angles must also congruent. That is to say, those two angles, they are equal to each other. So actually we proved that all three angles, 1, 2, 3, in triangle CYE congruent to all three angles, 1, 2, 3, in triangle CDM. Therefore, we proved that those two right triangles are similar to each other according to angle similarity rule. So I'll write it down. We actually proved the triangle CEY is similar. This is the sign of similar. Triangle CEY is similar to triangle CDM. according to angle similarity rule. I will repeat again. We actually proved that triangle CEY is similar to triangle CDM according to angle similarity rule. So what is angle similarity rule? Angle similarity rule is that if you prove that all three angles in one triangle congruent to all three angles in another triangle, then you actually proved that those two triangles are similar to each other according to angle similarity rule. And from the fact that triangle CEY is similar to triangle CDM, we will conclude that the following equality is true. We will conclude that CE over CY in the green triangle equals to CD over CM in triangle CDM. So I will write it down. We will conclude that CE over CY in triangle CYE equals to CD over CM in triangle CDM. Okay? Again, we conclude that CE over CY equals to CD over CM. So CE over CY. What is the value of CY? You can see from the drawing that CY, it is the radius of the middle circle, that is to say it equals to 2 units. So CY equals to 2, and it equals to CD. From the drawing you can see that CD equals to 1 unit. And what is the value of CM? CM equals to 3 units. So in total, we found out that according to equation number 3, CE over 2 equals to 1 over 3. Here we will multiply equation number 3 by 2, and we will get that CE equals to 2/3. So we found out that CE equals to 2/3. So we can write here that CE, this line segment, equals to 2/3. And what is the value of ED? From the drawing you can see that ED equals to CD minus CE. Again, CD minus CE equals to ED. So ED equals to CD minus CE. Again, ED equals to CD minus CE. So ED equals to CD. CD is 1 unit, and we already found out that CE equals to 2/3. So in total, we found out that ED equals to 1 minus 2/3. 1 minus 2/3 is third. So we found out that ED equals to third. ED equals to third. So here ED equals to third. And what is the value of OE? The value of OE, it is actually equals to OD plus DE. Again, OE equals to OD plus DE. OE equals to OD plus DE. So OE equals to OD. OD is 1 plus DE is third. 1 plus third is 4/3. So we found out that OE equals to 4/3 units. OE equals to 4/3 units. So we can write here that OE equals to 4/3 units. In the next step, we will join together points O and B by a straight line. OB, OBO, it is the radius of the semicircle, that is to say it equals to 4 units. And we will find out the size of this angle, angle OEB. Okay, we will find out the size of this angle, angle OEB. But first of all, we have a new rule, rule number 5. Rule number 5 states that the sum of the angles on one side of a straight line equals to 180 degrees. I will repeat again. The sum of the angles on one side of a straight line equals to 180 degrees. So I'll repeat again on rule number 5. Rule number 5 states that the sum of the angles on one side of a straight line equals to 180 degrees. So here we know that OC, it is actually the radius, OC is the radius of the middle circle, and as a radius must be, it is absolutely a straight line. Therefore OC is a straight line, and if you focus on this side of the straight line OC, the sum of its angles must be equal, at point E, the sum of its angles must be equal to 180 degrees according to rule number 5. So Here we have 90 degrees plus this angle that is actually angle OEB. The sum of those two angles must be equal to 180 degrees according to rule number 5, that the sum of the angles on one side of a straight line equals to 180 degrees. Okay, so according to rule number 5, 90 degrees plus angle OEB must be equal to 180 degrees. Here we will subtract 90 degrees from this equality, and we will get that the size of angle OEB it is actually 180 degrees minus 90 degrees is 90 degrees. So we found out that angle OEB is a right angle, it equals to 90 degrees. So this angle, angle OEB, is a right angle, it equals to 90 degrees. So here, if angle OEB is a right angle, then this triangle OEB, is a right triangle because it has one angle that equals to 90 degrees. So I will draw again the right triangle OEB, and we will find out the length of side EB. Okay? So I will draw again the right triangle OEB. So this is the right triangle OEB. We've already found out that OE equals to 4/3 units, and OB is the radius of the semicircle, it equals to 4 units. And the only thing that is missing is the length of side EB. And we will use the Pythagoras theorem in order to find out the length of EB. Okay, so in the right triangle OEB, according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse is OB, so the square of the hypotenuse is OB squared, and it equals to the sum of the squares of the perpendiculars, that is to say it equals to OE squared plus EB squared. So I will repeat again. In the right triangle OEB, according to the Pythagoras theorem, OB squared equals to OE squared plus EB squared. We know that OB equals to 4 units, so OB squared is 4 squared, 4 squared is 16. So 16 equals to OE squared. OE is 4/3, so OE squared will be equal to 4/3 squared plus EB squared. So here OB square is 16, OE square is 4 over 3 square, and EB square is EB square. Here 4 over 3 square is 16 over 9, so I will write it down. We get that 16 equals to 16 over 9 plus EB square. Here we will subtract from this equation number 4, 16 over 9, and we will get that 16 minus 16 over 9 equals to EB square. Here we will multiply 16 by 9 and then we will divide it by 9 in order to have a common factor with 16 over 9, and we will get that 16 times 9 over 9 minus 16 equals to EB square. Here 16 times 9 minus 16 is 16 times 8, so we'll get that 16 times 8 over 9 equals to EB square. Here 16 is 2 times 8, so we'll substitute 16 by 2 times 8 in equation number 4, and we will get that 2 times 8 times 8 over 9 equals to EB square. So here we will take a root out of this equation number 4, and we will get that EB equals to the square root of 2 times 8 times 8 over 9 . So here the square root of 8 times 8 is 8, and the square root of 9 is 3, so I write it down. We got that EB equals to 9 over 3 times square root of 2 units. So found out that EB equals to 8 over 3 times square root of 2 units. So in the next step we will prove that those two right triangles can go into each other. That the two right triangles can go into each other. So I will draw again those two right triangles, and we will prove that they can go into each other. Okay? So we will prove that those two right triangles can go into each other. First of all, we know that OA equals to OB equals to 4 units. Those hypotenuses, they are the radiuses of the semicircle, therefore they are equal to each other. So OA equals to OB equals to 4 units. And here we have a common side. OA, OE is a common side. It belongs to both right triangles. So OE equals to OE. It's a common side that belongs to both triangles. So by proving those two things, we actually proved that those two triangles can go into each other. So triangle OEA is congruent to triangle OEB. Triangle OEA congruent to triangle OEB. This is the sign of congruent. And they can go into each other according to rule number 6. Okay? So, what is rule number 6? Rule number 6 states that if the hypotenuse and the perpendicular in one triangle in one right triangle congruent to the hypotenuse and a perpendicular in another right triangle, then the two right triangles can go into each other. So I will read rule number 6 again. Rule number 6 says that if the hypotenuse and the perpendicular in one right triangle congruent to the hypotenuse and the perpendicular in another right triangle, then the two right triangles can go into each other. And here we actually proved that the hypotenuse OB and the perpendicular OE in the right triangle OEB is congruent to the hypotenuse OA and the perpendicular OE in the right triangle OEA. Therefore, we proved that those two triangles can go into each other according to rule number 6. Okay, we proved that triangle OEA can go into triangle OEB according to rule number 6. And from the fact that those two right triangles can go into each other, we will conclude that AE equals to EB. AE equals to EB. I will repeat again, we will conclude from the fact that those two triangles can go into each other, we will conclude that AE equals to EB according to the rule that corresponding sides in congruent triangles are equal to each other. So those two right triangles can go into each other, therefore the corresponding sides AE and EB will be equal to each other. That is to say, AE equals to EB. And what is the value of AB? From the drawing, you can see that AE equals to, from the drawing, what is the value of AB? AB equals to AE plus EB. You can see it clearly from the drawing. AB equals to AE plus EB. Okay, you can see from the drawing that AB equals to AE plus EB. But we have already found out that AE equals to EB, so we can substitute AE in this equality by EB, because AE equals to EB. So we'll do it and we'll get that AB equals to EB plus EB. That is to say, AB equals to 2 times EB. And we have already found out that EB equals to 8 over 3 times square root of 2 units. Okay, so in total, we found that AB equals to 2 times 8 is 16, so in total AB equals to 16 over 3 times square root of 2 units. Again, AB equals to 16 over 3 times square root of 2 units, or in terms of numbers, AB equals to 7.54 units. I'll repeat again. AB, the chord that we are looking for, equals to either 16 over 3 times square root of 2 units, or in terms of numbers, AB equals to 7.54 units. We can see it also in the original drawing. In the original drawing, here AB, the length of chord AB, it equals to either 16 over 3 times square root of 2 units, or in terms of numbers, AB equals to 7.54 units. Okay, so now I will summarize the lecture. Actually, we wanted to find out the length of chord AB. And we have here the semicircle, and inside this semicircle we have 2 small circles. Those 2 small circles are identical. In the middle we have the middle circle. This middle circle is perpendicular to the semicircle at point O. Point O, it is also the center of this semicircle, and point C is the center of the middle circle. We know that PQ equals to 8 units. And PQ, it is the radius, PQ is the diameter of the semicircle. And the diameter of any circle is twice as large as the radius. So if the diameter of the semicircle equals to 8 units, then the radius will be equal to 4 units. That is to say, PO, that is the radius of this semicircle, will be equal to 4 units, and OQ will be also equal to 4 units. Likewise, OX, that is also the radius of this semicircle, will be equal to 4 units. But OX it is not only the radius of this semicircle, but it is also the diameter of this middle circle. So we know that the diameter of this middle circle equals to 4 units. Therefore, the radius will be equal half of it, so the radius of this middle circle will be equal to 2 units. That is to say, the radius xc of this middle circle will be equal to 2 units, and the radius OC of this middle circle will be equal to 2 units. Likewise, the radius CY of this middle circle will be equal to 2 units. Okay, in the next step we connect together points M and C by a straight line. MC is the distance between the center of this small circle and the distance between the center of this middle circle, and those two circles, they have external notch between them at point Y. Therefore, the distance between their circles will be equal to the sum of the lengths of their radiuses. That is to say, it will be equal to r plus 2, because r is the radius of the small circle and 2 is the radius, 2 units, the radius of the middle circle equals to 2 units. So in total we found out that MC equals to r plus 2. Then from the center of this small circle, so we actually joined points M and N by a straight line. MN is the radius of this small circle, and N is the point of tangency of tangent PQ with this small circle. And we have the radius MN that is drawn to the point of tangency, that is to say, it is drawn to point N. Therefore, the tangent PQ will be perpendicular to this radius. That is to say, this angle equals to 90 degrees and this angle also equals to 90 degrees. Likewise, we have the radius CO of the middle circle that is drawn to the point of tangency. That is to say, it is drawn to point O, that is the point of tangency of tangent PQ with this middle circle. Therefore, the tangent PQ will be perpendicular to this radius. That is to say, this angle equals to 90 degrees and this angle also equals to 90 degrees. From point M, that is the center of the small circle, we drew perpendicular to CO. So this angle equals to 90 degrees and this angle equals to 90 degrees. We define the touching point between the perpendicular and CO as point D. We define this point as point E, and then I do again the quadrilateral MNOD and the right triangle MCD. Okay, here is the new drawing, and I presented to you, well, we know that AB is parallel to PQ. AB is parallel to PQ. And then I presented to you rule number 1. According to rule number 1, corresponding angles between parallel lines are equal to each other. So here we have those two angles, angle CEY, this angle, and angle CON, this angle. There are two corresponding angles that are located between the parallel lines AB and PQ, therefore they are equal to each other according to rule number 1. That is to say, this angle is a right angle, and it equals to angle CEY. So in total we got that angle CEY equals to 90 degrees according to rule number 1. We found out that angle CEY equals to 90 degrees according to rule number 1. Likewise, we have those two angles are defined as corresponding angles, and they are located between the parallel lines AB and PQ. Therefore, according to rule number 1, they are equal to each other. And this angle is a right angle, it equals to 90 degrees. So in total we got that angle CEB, this angle equals to 90 degrees. So angle CEB equals to 90 degrees according to rule number 1. Then I presented to you rule number 2. Rule number 2 states that the sum of the angles in any quadrilateral equals to 360 degrees. And if we focus at quadrilateral MNOD, according to rule number 2, the sum of its angles equals to 360 degrees. And this quadrilateral has 3 right angles, 1, 2, 3. And the sum of 3 right angles is 90 times 3, it equals to 270 degrees, plus the size of the fourth angle that we define this angle x must be equal to 360 degrees according to rule number 2. I will repeat again. The sum of the 3 angles, that is 270 degrees, plus the size of the fourth angle must be equal to 360 degrees according to rule number 2, that the sum of the angles in any quadrilateral equals to 360 degrees. We subtracted 270 degrees from this equality, and we got that angle x equals to 90 degrees. That is to say, this angle is a right angle. So in quadrilateral MNOD, this quadrilateral, we have 4 right angles. And we also have rule number 3 that states that any quadrilateral that has 4 right angles must be at least a rectangle, if not a square. And because of the fact that this quadrilateral MNOD has 4 right angles, we relate to this quadrilateral as a rectangle according to rule number 3. So quadrilateral MNOD is a rectangle according to rule number 3. And we have also rule number 4 that states that the opposite sides of a rectangle are equal to each other. And we know that Mn is the radius of the small circle, that is to say Mn equals to R. So here Mn equals to R, and according to rule number 4, Mn equals to DO, because those two sides are opposite to each other. Okay, so Mn equals to DO according to rule number 4, that the opposite sides of a rectangle are equal to each other. Mn equals to DO according to rule number 4, but we have already found out that Mn equals to R. So from this equality we will conclude that DO also equals to R. DO also equals to R. So we can write here that DO equals to R, and we know that CO is the radius of the middle circle, that is to say it equals to 2 units, and DO equals to R. And what is the value of CD? CD equals to CO minus DO. Okay, so CD equals to CO minus DO. So CD equals to CO, that is 2 units, and DO, that is R. So in total we found out that CD equals to 2 minus R. Here CD equals to 2 minus R. Okay? Then what is the value of MC? The value of MC is R plus 2. We've already found out that MC is R plus 2. So MC equals to R plus 2 and the CD equals to 2 minus R. So we focus on the right triangle CDM. According to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars in any right triangle. So in triangle CDM, it means that CM square equals to CD square plus MD square. CM equals to R plus 2, so CM square will be equal to R plus 2 square. So CM square equals to R plus 2 square. It equals to CD square. CD equals to 2 minus R, so CD square will be equal to 2 minus R square plus MD square. So in total we got that R plus 2 square equals to 2 minus R square plus MD square. We opened the brackets in both sides of equation number 1 and we found out that R plus 2 square equals to R square plus 4R. 2 minus R square, it is actually 4 plus 4R minus 4R plus MD square. Here we have R square on both sides of equation number 1, so R square will get cancelled, and we have 4 also in both sides of equation number 1, so 4 will also get cancelled. And what is left from this equation number 1 after we cancel those expressions, what is left in this side is it is actually 4R, and the other side what is left is actually minus 4R plus MD square. Here we added 4R to this equation number 1, and we got that 4R plus 4R is 8R, and 4R minus 4R is 0. So in total we got that 8R equals to MD square. Here we took a root of this equation number 1, and we got that MD equals to the square root of 8R. We know that 8 is 4 times 2, so we substituted 8 in this equation number 1 by 4 times 2, so we got that MD equals to 4 times 2 times the square root of 4 times 2 times R. The square root of 4 is 2, so in total we got that MD equals to 2 times square root of 2R. So here we can write down that MD equals to 2 times square root of 2R. And according to equation, to rule number 4, the opposite sides of a rectangle are equal to each other. That is to say, MD equals to NO. MD equals to NO according to rule number 4. But we have already found out that MD equals to 2 times square root of 2R. So from this equality we will conclude that NO also equals to 2 times square root of 2R. Okay? Then we connected together points M and O by a straight line. We did the same in the original drawing. We connected together points M and O by a straight line. Then we connected together points A and M by a straight line. AM is the radius of this small circle, that is to say it equals to R. And AO is the radius of the semicircle, that is to say it equals to 4 units. And what is the value of MO? MO equals to AO minus AM. Again, MO equals to AO minus AM, AM equals to R, and AO equals to 4. So in total we got that MO equals to AO, that is 4, minus AM, that is R. So MO equals to 4 minus R. So we can write here that MO equals to 4 minus R. And we already found out that MN equals to R and NO equals to 2 times square root of 2R. So we focused on the green right triangle and we implemented the Pythagoras theorem in the green right triangle. That is to say, in triangle M and O, according to the Pythagoras theorem, MO square equals to NM square plus NO square. MO is 4 minus R, so MO square will be equal to 4 minus R square. and it equals to mn square. Mn is r, so mn square will be equal to r square plus no square. No is 2 times square root of 2r, so no square will be equal to 2 times square root of 2r square. So in total we got that 4 minus r square equals to r square plus 2 times square root of 2r square. We open the brackets of both sides of equation number 2. 4 minus r square is 16 plus r square minus 8r. And the square of 2 times square root of 2r is 8r. Here we have r square on both sides of equation number 2, so r square will get cancelled. We added 8r to this equation, equation number 2. So 16 minus 8r plus 8r is 16, because minus 8r plus 8r is 0. And here 8r plus 8r is 16r. So in total we got that 16 equals to 16r. We divided this equation, equation number 2, by 16, and we got that r equals to 1 unit. So we found out that the radius of the small circle equals to 1 unit. Okay, here r equals to 1 unit, r equals to 1 unit, and CD equals to 2 minus r, and r equals to 1. So CD equals to 2 minus 1. 2 minus 1 is 1, so CD equals to 1 unit. Then we focused on the right great triangle CD, CEY, and on the right triangle CDM, and we proved that those two right triangles are similar to each other. We focus on the right great triangle CYE, and the right triangle CDM. Why they are similar to each other? First of all, we know that those two angles, they are equal to each other, they are right angles. So angle CY in triangle CY equals to angle CDM in triangle CDM, and they are both equal to 90 degrees. They are right angles. And we also know that this angle is a common angle. It belongs to both triangles, so angle C equals to angle C is a common angle that belongs to both triangles. Angle C equals to angle C is a common angle. And we also know that those two angles, they are equal to each other according to third angle theorem. Okay, so angle CYE in triangle CYE equals to angle CMD in triangle CDM according to third angle theorem. So what is third angle theorem? Third angle theorem states that if two angles in one triangle congruent to two angles in another triangle, then the third pair of angles must also congruent. And here we proved that this is the first pair of angles that congruent. This is the second pair of angles that congruent. This angle equals to itself. So we have here two pairs of angles that congruent in those two triangles. Therefore, according to third angle theorem, the third pair of angles, those two angles, must also congruent. Okay, so angle CYE equals to angle CMD. Okay, so we actually proved that all three angles in triangle CY, 1, 2, 3, congruent to all three angles, 1, 2, 3, in triangle CDM. Therefore, we proved that triangle CY is similar to triangle CDM according to angle similarity rule. And what is angle similarity rule? Angle similarity rule is that if you prove that all three angles in one triangle congruent to all three angles in another triangle, then you actually proved that those two triangles congruent to each other according to angle similarity rule. And from the fact that triangle CY is similar to triangle CDM, we will conclude that the following equality is true. We will conclude that CE over CY in triangle CY equals to CD over CM in triangle CDM. So CE over CY, CY is 2 units, so CE over 2 equals to CD. CD, we know that CD equals to 1 unit. And CM equals to 3 units. So in total we will get that CE over 2 equals to 1 over 3. We multiply the equation number 3 by 2 and we got that CE equals to 2/3. Okay, CE equals to 2/3. And actually DE equals to CD minus CE. That is to say DE or ED equals to CD minus DE. That is to say ED equals to CD, that is 1, CE that is minus that is 2/3. So ED equals to 1 minus 2/3. That is to say ED equals to 1/3. So we found out that ED equals to 1/3. And what is the value of OE? You can see from the drawing that the value of OE is OD plus DE. OD equals to 1 and DE equals to 1/3. So in total OE equals to 1 plus 1/3. That is to say OE equals to 4/3. Okay? Then actually we proved that those two right great triangles can go into each other according to first of all we actually proved that this angle is a right angle. So I go again the right triangle OEB, and we proved that this angle is a right angle. And we know that OX is actually the radius of the semicircle, therefore it is a straight line. And we have rule number 5 that says that the sum of the angles on one side of a straight line equals to 180 degrees. So if we focus on this side of the straight line OX or CO, the sum of the angles on this side at point E must be equal to 180 degrees. So this angle, that is a right angle plus angle OEB, must be equal to 180 degrees. I'll show it here. We know that CO as the radius of the semicircle, it must be a straight line. And we have rule number 5 that says that the sum of the angles on one side of a straight line equals to 180 degrees. So this angle, that is a right angle, plus the size of angle OEB, must be equal to 180 degrees according to rule number 5. I'll repeat again. The angle that equals to 90 degrees plus angle OEB, this angle must be equal to 180 degrees according to rule number 5. We subtracted 90 degrees from this equality and we got that angle OEB equals to 90 degrees. That is to say, this angle, it is a right angle, it equals to 90 degrees. So if this angle is a right angle, then triangle OEB is a right triangle. So I draw again the right triangle, triangle OEB, and we know that OE, we already found out that OE equals to 3 over 4 units. OB is the radius of the semicircle, it equals to 4 units. And the only thing that is left to find is to find out the length of side EB. And we found out the length of side EB according to the Pythagoras theorem that states that the square of the hypotenuse equals to the sum of the squares of the perpendiculars. So in the right triangle OEB, it means that OB square equals to OE square plus EB square. OB equals to 4 units, so OB square is 4 square, 4 square is 16. OE equals to 4 over 3 units, so OE square will be equal to 4 over 3 square plus EB square. 4 over 3 square is 16 over 9. So in total we got that 16 equals to 16 over 9 plus EB square. We subtracted 16 over 9 from this equation number 4, and we got that 16 minus 16 over 9 equals to EB square. Here we multiplied 16 by 9 and then we divided it by 9 in order to have a common factor with minus 16 over 9, and we got that 16 times 9 over 9 minus 16 equals to EB square. 16 times 9 minus 16 is 16 times 8, so in total we got that 16 times 8 over 9 equals to EB square. And 16 equals to 8 times 2, so we substituted 16 by 8 times 2 in this equation number 2. So we have in total that 2 times 8 over 9 equals to EB square. Here we took a root out of this equation number 2, and we found out that EB equals to the square root of 2 times 8 over 9. The square root of 8 times 8 is 8, and the square root of 9 is 3. So in total we got that EB equals to 8 over 3 times square root of 2 units. Then we actually proved that those two green right triangles can go into each other. So I'll copy those two right triangles again, and we prove that they can go into each other. We proved that those two right triangles can go into each other. Why they can go into each other? Because first of all, we know that OA equals to OB equals to 4 units. And OE is a common side that belongs to both triangles, so OE equals to OE. So by proving those two things, we actually proved that triangle OEA is congruent to triangle OEB according to rule number 6. And what is rule number 6? Rule number 6 states that if the hypotenuse and a perpendicular in one right triangle congruent to the hypotenuse and the perpendicular in another right triangle, then the two right triangles can go into each other. And we actually proved that the hypotenuse OA, the hypotenuse OA and the perpendicular OE, triangle OEA, can go into the hypotenuse OB and the perpendicular OE, triangle OEB. Therefore, we proved that those two triangles can go into each other according to rule number 6. And from the fact that those two triangles can go into each other, we will conclude that AE equals to EB. AE equals to EB according to the rule that corresponding sides in congruent triangles are equal to each other. Those two triangles can go into each other. Therefore, the corresponding sides AE and EB will be equal to each other. That is to say, AE equals to EB. And what is the value of AB? AB equals to AE plus EB. AB equals to AE plus EB, but we have already found out that AE equals to EB, so we can substitute AE by EB. So we did it, and we got that AB equals to EB plus EB. That is to say, AB equals to 2 times EB. We already found out that EB equals to 8 over 3 times square root of 2 units. So in total we got that 2 times 8 is 16, and AB equals to 16 over 3 times square root of 2 units, or in terms of numbers, AB equals to 7.54 units. I'll repeat again. Here, the length of chord AB equals to either 16 over 3 times square root of 2 units, or in terms of numbers, the length of chord AB equals to 7.54 units. Okay, thank you very much.